Hello, everybody. Welcome to this TIP webinar, Open Automation. The vision is now fully automated. Thank you very much for joining today. My name is Vishal Mathur. I'm the Global Head of Engagement at the Telecom Infra Project. Very briefly, make sure that you understand who TIP is. We are a member association, a not-for-profit association, and we have a group of organizations, companies from the telecoms industry, including telcos, system integrators, vendors, equipment manufacturers, software providers, startups, research institutes, all coming together, looking to work together as a collective to change the pace of innovation in telecom networks. This topic today is actually front and center on many mouths. We're looking to understand truly how automation can be built as a capability, especially as the industry is moving through a paradigm shift in the way networks are built, from proprietary-based solution stacks with closed interfaces to open interfaced disaggregated models. Today, we have a great speaker lineup, not only from the demand side in the operator sphere, on specifically looking at the opportunities and challenges and the need sets in the telco industry, but also from the vendor and software side as well. Those players out there who are experts in the field of open automation. If we can, let's bring up some slides here and then talk through who we have today. So allow me to introduce our speakers, and if you can introduce them to the stage. We have Aryan from VodafoneZiggo. Nice to meet you, Aryan. Would you mind introducing yourself, please?
Of course. Aryan Eken. I work at VodafoneZiggo in the Netherlands, senior architecture manager, heavily involved in networking operations, and also been trying to automate the environment we have. So thanks for having me.
Thank you very much, Aryan. Thanks for joining today. Looking forward to your presentation. Next is Lloyd from MTN Group. Please introduce yourself, Lloyd.
Yeah, thanks, Vishal. My name is Lloyd Mpashele. I'm a general manager in MTN Group. So I'm responsible for the transport portfolio and more recently OSS and tools as well. So this looks over 21 of our operations in Africa and the Middle East.
Brilliant, excellent. Aryan and Lloyd will kick off the proceeds with some very good presentation and understanding of what telcos are looking for in this space. But let me move to the other side of the fence and introduce Roy from Atrinet.
Hey everyone, pleasure to be here. I'm Roy Silon, VP Technologies at Atrinet. We are a software vendor focusing on network automation. We have a core product called NetAce, which enables open automation for all breadth and sides of the network. Personally, I've been at this for more than 20 years, and I would be happy to share some of my experience later today.
Fantastic. Nice to meet you, Roy, and look forward to your presentation and the Q&A afterwards. If we can move to the agenda slide, let's just talk through what we've got today. So we'll have as I said, an introductory presentation from Erhan and then followed by Lloyd, looking at exactly what the primary challenges are in the space of bringing network automation and open automation in the spirit of building a optical transport network. And from there, we'll go and do a bit of a deep dive into understanding from Atrinet as well, what their views are and the development of the capabilities that the industry will need. I hope then Aryan will follow up when looking at the roadmap and cooperation that we need within the TIP community to drive this forward. And then from there, I'd like to then drive forward a Q&A. So please keep on putting your questions into the chat box. We'll start to collate those and start to use the session at the end to try and ask our distinguished speakers some of the views on this space. So without further ado, I think we'll go straight to the next set of slides, and I'll pass over to Aryan.
Yes, thank you very much. If you can exclude the slides. So yes, what is important for operators, what we struggle with, is to have one management system. We have several vendors, different management systems, which are all great for a particular vendor. They do a good job, but we're looking for a unified management system. Not only unified, but also we're looking for something, of course, that is not too expensive. That's why I joined this open initiative, whereby we can use the resources and the intellect of the community to build this system. It needs to be agnostic. Again, to make the point, we have a lot of vendors. There's modules out there that strive towards this, but still, there's software out there that does not really comply with the latest standards, and so we are stuck with network translation modules, which is all understandable. But that's what we as an ISP are looking for. I'm looking for a management system that can control all the environment I have, and also allows me, that doesn't limit me to other vendors that have a interesting product. It goes without saying, of course, we are a carrier. So it needs to be carrier grade available. The software needs to be impeccable. It's okay if something is not there's a power out or something like that. The system is still running. So not like that it's all in one machine, and it needs to be at several places, so to say, to make sure that the MS is always available. Also, what is very important to us as well is the zero-touch provisioning. We struggle with that, so we have some modules. Again, the company I work for that have modems. When you plug them in, they come online, but we don't have that, for instance, for the B2B CPEs. We still manually need to provision them. Same as the core. Now, the core is, of course, we don't have that many devices. What we strive for in the end is that we have all the configurations available based on the models, predefined models we have. And an installer can install the device, plug a cable in, and the whole device will come online. That's what we're looking for, to make it very scalable and very easy. You can go to the next slide, please. So also what we're looking for is in the end-to-end process. At the moment, I see that we still need to have several people interfering in the process. So we might have a template that we apply on devices, but still we need to get IP addresses, VLANs, all that kind of typical stuff. We need to scramble together from Excel sheets. And that we want to fully automate. And it's not only the network configuration we're looking for, but also the services as well. And that is hard for us at the moment to realize. We're getting there. That's why we have this work group. And again, to make the point on performance, so zero-touch provisioning, that we are looking for the entire service to be zero-touch provisioning. So again, we have the configuration available, we install it, and it comes online for the entire end-to-end services which is needed. And also eventually we can alter it. We can alter it easily, or maybe the end customer can do it. A problem we have in the industry for a while, and there's been many great initiatives and many great products, but the performance monitoring and fault management is somewhat limited. There could be a fiber cut somewhere, and we know the line is down, but it's hard for us then to figure out, who are the customers, what services do they have, and how long have they been down, what was the impact, etc. And also we need this, of course, to give feedback to the customer itself. The customer is looking for an SLA and wants to know exactly, what services were impacted. So that's also what we try to do with this as well, and we talk about with the speakers about this later as well. Go to the next slide. So this is what we want to see in automation, this slide. When the network needs a change, when we need to apply new services, when something new gets introduced, or capacity upgrades, this needs to all be catered for. Again, the other day I was talking in the company about how to automate this whole upgrades when we go from 10 gig to 100 gigs, and we still are struggling with fully automated. And then I was talking to some engineers that had some great ideas to use a portal, the provisioning all together, and then basically one person could not only do the deployment of the capacity, but also look at it, when it should be planned. So we get certainties, and it shouldn't be done during the day, but it can also be during the night. It can also be during the day if you got a good system. Again, the point that is very important. That's the most important thing for me. That it needs to be agnostic. It doesn't matter what command interface we have, or what language you use. It should be usable for all vendors we have. And it should, and also it should, when we have, for instance, it's always in the end goal is also when we have different iOSs, so operating systems, as I say, sorry about that. We should be able to do the automatic software upgrades, and it should be also when I have some versions that are N-4, it still can communicate to the system. So you never get a situation that all the softwares have the same version. So we also make sure that there's room for that as well. So basically, we're looking for flexibility. And the last point I want to make for now is that, of course, we're also very interested in these closed automation self-healing networks. We are taking the first steps on it. There's a lot of literature out there, so also a lot of companies that are working with this already. But it's key for us operators if we can make this whole operation and fault analysis proactive. So before human intervention is happening, before even somebody detects it, but we get it logged into our systems, and we know there's an issue, but nobody really notices it, and we can keep the outage as short as possible. That, of course, is very valuable to us and to our customers. So that's basically, in a nutshell, what we try to achieve.
Yeah, thanks, Armin. All right, so I'll take you through, the different tip transport aggregation initiatives, as a start. So, this journey has been quite an interesting one. I think of the 3 products that you are seeing over here, the DCSG is the one that's most popular. So, and the theme here is open and disaggregation. So today we have the DCSG, the DDBR, and Cassini. So the DCSG is the most popular one for the cell site, gateways. You may have heard that recently from an MTN perspective, we've done quite a large scale, commercial trial deployment that is happening in MTN Uganda. So we're really looking forward to the test outcomes, that are gonna come from there. There is some work that is taking place today with the DDBR. It's not entirely out there, but it is meant to serve the core part of the network. The capacities that relates to core backhauling, carrying the typical protocols like IP and PLS. And I think what we're looking forward to in this space is also the democratization of the environment, opening up the ecosystem, allowing the vendors to compete and provide value. So Cassini, more a data center, high capacity product that is used, for data center interconnection, and also the service provider backhaul use. I know of a few cases, in Africa as well, where the product is being deployed, and it seems to be working well. So the question that we might have is that with this open and disaggregation that we're bringing in, one, I think there's a question of introducing complexity. Today we have the software and the hardware there together. And now, we'll have the hardware separate from, the software. And, the big question may be then, how do we bring all these elements, together to function, under a unified managed, system? And this is where now, we look at what is it exactly that, we're trying to achieve from an open automation, perspective. And, the end goal is really to ensure that we are able to orchestrate across these multiple, domains, ensuring that, the interfaces are standardized, working cooperatively with our partners, some of which we'll be presenting, today to design, to validate and come up with this, this library of composable automation building blocks that, we are able to, to reuse. Can I have the next slide, please? Okay, so I touched on a little bit on what is happening, today. So if you look at, the two pictures, it gives you a sense of where we are today and what the future will look like. So today pretty much is the complexity of the, the multi-vendor domain, but also, the siloed nature of the network. I mean, talking about transport specifically, you have the microwave, you have the IP, and the optical domains that are, for all intents and purposes, independent, domains that are not entirely aware, of each other, which makes it very, very difficult, to come up with end-to-end, processes that cover the entire network. Some of these ambitions that we're having around, automation and use cases around zero-touch provisioning and so forth become, very, very, very complex. And this is where we are not able to make full use of, artificial intelligence, machine learning, and so forth to its full capacity. And with the initiatives that we've embarked on in, TIP, we then, start to move towards that, desired end state where we are able then to bring all these elements together for them to be aware of each other and, being able to execute the end-to-end orchestration. So just looking at the picture on the right, these are the building blocks of, the architecture that, we design in order for us, to come there. Right at the bottom, it is this, products that I spoke about, like the DCSG, the DDBR, and, and so forth, that are supported, by these, mandatory use cases for SDN, transport. Some of you that are aware of what is taking place in TIP, we've got what we call OOPT, which is Open Optical Packet Transport Project Group. And in there, there's a subgroup called MAST, which I just spoke about, which came up with the open, SDN architecture. And this is what, is going to assist us as operators to come up with a unified architecture that will help accelerate, the automation that we so aim for. And, I spoke about, OPTN, all these elements come together to support the ambition that we can be able to achieve, this automation that we are, gunning for. So this is really what we're looking for and what we are, we are aiming to achieve from a IP, optical, and also a microwave, perspective. All right, so we can move to the next slide, please. All right, I think Ariane touched a little bit on these elements of what, the service providers want to see in network automation. I think, my key message, from here is that with all the, the complexity, the disaggregation, all of these elements that are coming from, different, perspective, different points that needs to come together, operate on a basis of open APIs, standardized interfaces, and all of that. There need to be a single point of accountability, which will then make it easier. But I also think that it will help, bring confidence that with the path that we are taking, going the automation, open and disaggregated route, we are not introducing, more complexity on top of what we are having today. Therefore, it just, helps if we come up with that single point of accountability to ensure that all of these elements are all harnessed and put together from there. The whole point about the unified language that needs to be overcome, that also talks to what I've touched on before, to ensure that although we sourcing from different places, we are able to make use of a common language to simplify the integration as well. The machine learning insights also very, very important, because as the network becomes big and complex, it is important that those elements of intelligent and data gathering to help optimize the network then becomes very, very, very key. Next slide, please. So that was the end of my presentation. So now I'll call upon Roy to take you through the Atrinet presentation.
Thank you, Lloyd. So hello, everyone. My section today is focused on network discovery, real-time inventory discovery. Basically, the tip graphics, I really like them. You can see one of them at the bottom left here, and you've seen them at Ariane and Lloyd segments. They're really nice. They show the network as a really graphical, simplified, beautiful thing, but we all know that's not really the case. The networks are much more complex and sometimes even messy creatures. And as the networks become even more complex, virtualized, containerized, disaggregated, you need to introduce a very high level of automation in order to manage them successfully. And you cannot manage what you cannot see. Your software automation cannot really manage properly your network if it doesn't have the proper information about it. And this is where basically accurate network inventory comes in. And accurate network inventory can only be achieved by automatic deep discovery and reconciliation processes looking at the network itself. You cannot rely on manual updates of the inventory system. This concept has quite failed and will not be able to continue living on as the networks become really bigger and more complex. For example, if you're looking at Open RAN and OOPT, you actually are going to have much more elements in numbers and much more disaggregated and new types of elements to monitor and discover, because now you don't have just, for example, an eNode B. The eNode B is completely split horizontally and vertically now to 6 potential elements. All of them can be running in multiple places and jumping around. And you must have the capability to update your inventory in real time, so your various service fulfillment and service assurance parts of the network automation framework would be able to work successfully. So next slide, please. What do we see at Atrinet? And of course, based on our experience and discussions with various operators in terms of the requirement for the deep discovery required for open automation. So we must be able to build a 100% accurate active inventory for all types of the network, whether they're the more legacy physical parts or the newer physical parts that are still, of course, coming around. The network will never be completely just software virtualized containers. There would always be a mix. And of course, we also need to support either the sort of medium-term virtual components that are now already deployed and the future-looking containerized cloud network types that are running. The deep discovery should be completely dynamic and as real-time as possible, because the network itself, as it is now being managed more and more automatically, is changing very rapidly. from the exposure capabilities that are required from such an engine, really you must cater to different type of entities. Either the operations team that would need a proper web UI, or APIs, so external systems, third-party system would be able to digest the data. And by the way, if we're talking about AI/ML, so this is definitely applications that would need to have also the inventory information, the full-time visibility of what's happening to the network, in addition to just the fault management and performance monitoring information that most of them are currently using in order to really provide good benefits and true automated decisions. Now, once you have this type of deep discovery, real-time deep discovery, you can really have this as an enabler for a high degree of service fulfillment. It can allow you to maximize your infrastructure utilization and reduces these erroneous configuration and fallouts that can sometimes take weeks to recover from, as I'm sure all of the service operators here are familiar with. Okay, so next slide, please. Now, when we're talking about network discovery, and you might have heard these sort of buzzwords like network is the master, and the network is the real inventory, and the database. This is all good and nice, but in reality, network discovery is even not as simple as that, because you cannot just rely on the network really as the true master and just take whatever you read from the network and overwrite what's there in your inventory system. Life is simply not as simple as that. Because in your inventory system, you might have various planned services, various planned new elements that are going to be deployed or provisioned. And if you read the network now, of course, these are not residing there because they have not been deployed yet. There as planned, but you cannot just now override these planned artifacts in your inventory. It will screw up your complete planning schedule. On the other hand, for example, there might be some technicians that are still doing sort of these emergency manual procedures live in the network and changing some stuff. And these configurations cannot just be completely overwriting what's ever there in the inventory, because these technicians might have done something that fixes some urgency, but in long term, maybe some of this configuration have to be tweaked a little bit in order not to affect other parts of the network. So in order to really allow for a real-time network-driven inventory, you must have two parts in the discovery leg. You should have the discovery engine that knows how to connect and communicate with the various parts of your network, whether directly via the devices or via some controllers or cloud management services. And then take this discovered information and first of all compare it via whatever sitting in your inventory system, find any discrepancies, any differences in the discovered data, and then offer various reconciliation operations. Now, some of these reconciliation can be automatic according to some predefined set of rules, but some of them should trigger some workflows with maybe some manual parts. These workflows should be able to integrate maybe additional third-party systems in order to gather some information that would help to make the reconciliation. Only at the end of this procedure, the decision is made whether to really overwrite what's there in the inventory or actually maybe trigger some process to correct the network itself so it fits what's in the inventory system itself. Okay, so next slide, please. And if we're talking forward looking, then the network is going to become more and more complex. It's good that it's going to become more and more complex because we're using new virtualization, cloud resources, new vendors are entering the market and are offering various network operating systems that can run on white boxes. All of this eventually is going to reduce greatly, this is the hope, and I think we already see the fruits of this, reduce the capex for the service providers. But on the other hand, it's going to increase the complexity of the network management. So how does this complexity comes into play, for example? So if we're looking at the network 5 years ago, the network was messy, but it was mostly comprised out of physical devices, all coming from the same vendor, the NOS and the box itself, and you would have to discover just one element, either by communicating directly with it or by some controller. Now, when the network is becoming more virtualized, containerized, and cloud-based, you have much more elements coming into play. The elements can move around due to some scale-out, scale-in considerations of the cloud or the private data center. There are much more controllers and orchestrators that have to be consulted in order to really get the end-to-end view. And your network discovery engine should be able to really gather the information from all of these different types of network elements, controllers, orchestrator, different resources, in order to really populate your inventory with the full end-to-end accurate information. And if we go to the next slide, as you might have already imagined, part of the NetAce Open Automation Network framework is one of our crown in the jewel in the crown, our prized network inventory deep discovery and reconciliation engine. And you're of course welcome to contact us for more details. Actually, I would like to use this slide for touching a little bit on what I like about TIP. So as you can see, NetAce allows other functionalities such as service activation, configuration, performance monitoring, and fault management. There is a true sense of collaboration in TIP. And so last slide from my side is a little bit on the next slide, please, is a little bit on the non-functional attributes that are required from a network automation solution today. So, of course, everyone is talking about the cloud and the virtualized world. The same way your CNFs and VNFs should be able to run on multiple cloud domains, your network automation solution also should be able to do the same. And of course, in telecom, everything is much more complex than in other sectors. So a true network automation solution should not just be a fully cloud native solution that can run on the cloud. It should be cloud agnostic. So it should be able to run on AWS, Azure, and the Google Cloud, and not be tied down to just one of them. And it should also be a quite modular and flexible solution and be able to run part on the cloud and part on-prem to support various mix and matches, edge use cases. And these are important things that we recommend that when you look on your network automation provider is to really take a look whether this solution can cater to all of these different requirements.
Yes, so the next couple of slides are just on where we are, and it's also a call. So so just to let you know, so of course we had an introduction from Atrinet, and so and we're working now on the provisioning of the layer 2 and layer 3 as a first assignment. We'll show some slides later on what's going on there. We also engaged with Bullrun, it's very promising in C2 networks. And again, we're cooperating with the OTP and the Open RAN, as Lloyd explained already. But this is also, of course, a call for everybody who's interested in this and wants to join us. So we got a lot of appetite for making this happen, and we come to the questions and answers a bit later. But again, the way I look at this, just to share my passion for this, this is the first time, we are working on a platform where we have a bus basically connecting all the APIs together, and we can do the north and the southbound, and it's a scalable model. With all the modules we're building a framework, a cathedral, as I sometimes joke, which is going to be very powerful. And in all my days in telecom, I've been here for 20 years. I've never seen something like this being developed, and I also, of course, like again to stress the openness of this whole development we have as a community. So that's really appealing to me. There's no vendor locking, it's all open, and we can do this together. So again, we're looking for members. At the moment, we have the ones I just mentioned. And please join us, what we're trying to do here. Lloyd, you want to take the next slide?
Yes, I'll do that. Thank you so much. So I think maybe one key message that we also want to send across is that the idea is really not to reinvent the wheel and come up with our own tip standards and so forth. So it is important for us to cooperate, and I think that has come very strongly in the MAST project group with the development of the open SDN architecture. So this particular slide here, we're talking about that dimension of cooperation. So this is leveraging the resources that exist today within the TIP community. So in this particular case, how the OOPT is cooperating with our Open Automations project group, it's around these three areas of business service use cases, the end-to-end automation APIs, as well as the automations library. So this is a big deal for us, and I think with what we are doing today, with Atrinet is testament to that, with some of the resources that they've pulled, from a lab, resources perspective, to execute the trial of these use cases that we will be trialing. So from a business use case perspective, here we're talking about automation of business services, to assist with the optimization of processes and to also improve efficiency. So those resources are there from OOPT for us to use. From an end-to-end automation APIs perspective, I think this is a critical area where the different softwares come together. So this is a good contribution from OOPT. To us in open automation to, excuse me, to really help drive that end-to-end service integration state that I alluded to in my earlier presentation, that it is really the Achilles heel for us today, and this will go a long way because in that particular area, there's no need for us to reinvent the wheel. So from an automations library perspective, OOPT is kind enough and willing to share some of the templates and scripts into a unified library that we spoke about earlier between myself and Ariane. To make sure that it's easy, for us to, stitch up basic services upturn, and also, the network optimization. So in a nutshell, these are, the three key collaboration, points between us and OOPT. And of course, a few more other things that, they are willing to support our project group as and when we make those requests. So so I'll hand over to Ariane maybe to just take us through the next slide, please.
Yeah, so this, thanks, Lloyd. So this is some draft we made on how we see what we can do in a time frame. So I'm not going to step through and read them all out, but the general view is, again, we're working on the layer 2, layer 3 across the entire network, so all devices need to be incorporated. Same goes with zero-trust provisioning, so that's on a major focus we're trying to work now. What's also important for us as an industry that we, of course, get real-time ordering. So we want to get the Amazon experience where you want something as a customer and it's immediately there. Now that requires a lot of intelligence and the framework we spoke about, but that's something that's getting more and more speed, and it's getting more importance. That's what I'm looking for. Together with that, of course, we also want to cater the customer much better. We want to show the customer what the bandwidth he's been using, or how many packets he's being dropped. Marketing might have an issue with this, right? Because maybe they don't want to show this at all. But I think we should do it. We should do it because a lot of companies outside our industry are doing the same thing. And as an example, I mentioned the CR records. So during, you might pay a monthly fee, but also based on the voice minutes you use. And we should be able to tell the customer at any moment in time during this month how much the bill is at that moment. So show them, what numbers they've been calling, what the tariff and that kind of stuff. So it needs to be much more customer friendly and not just send the bill and here you go. We need to step away from it. We need to get to the modern technology basically. Roy already mentioned what's very important to us as operators, of course, was going back to the network topology is key to us when when we install something, when we deploy a new interface, new services on it, it's instantly is recognized. A lot of systems already talked about, so I won't go too much into it, but a lot of systems we need to manually update. And manual, there's always somebody who's busy on another task, so it gets corrupt and it's useless in the end, to be honest. And though a lot of people try it, I don't want to dismiss anybody. Based on with that, not only comes the topology, but we also want to use see how a customer goes through the network. So a customer have 5 different services. For each of the services, we want to see how they go through the network. So when something goes down, we know exactly what the effect is, and also of course the protocol status. We can go into detail that as well, but we just want a layered approach on what is happening on a network basically. One thing I mentioned here is the optical layer. That's Lloyd already talked about it as well. But I'm also, what we see now is layer 2 and 3 we can be doing, but we also want, of course, the optical devices themselves. There's also have ways to discovering, and also ultimately the fiber path. So we also combine it with the physical topology we have. We all put it together, and then we got a very good understanding what's happening on our network. One thing we always struggle with in the company I work with is when we do a change, what is the impact? It's hard to determine. Now this will also help. So we just say we're going to touch this device, this will be the impact on these customers, and these services will be impacted. When is the fiber going down, if there's an issue, we also want to determine, what is the customer still, is it an outage, or did the customer lose redundancy? And sometimes, the fault is solved, so the P1 is gone, but still the redundancy is not put back in place. So we need to have triggers doing that as well, making sure that we have a constant health check on a network. Another thing, that we thought about is also have a clear cockpit for operations. At the moment, a lot of operators, they have one screen for the remedy tickets, another one to show the customer impact. Well, I can go on, right? And a big wall where the network is being drawn. I think we should strive for, as an initiative here to make sure the operator gets an alarm in. Immediately, it's possible to zoom into where the problem is in the network to show what the common denominator is, right? So there might be faulty laser or faulty fiber or whatever, and this is causing all these customers behind this device causing issues. Together with automatically generating a ticket, all this stuff, it should be, we can be much faster. All, of course, with the aim to resolve tickets much faster and get a much faster SLA. Also, what happens, we make a change and we prepared it well, 4 eyes reviews, but still an outage occurs. So we need to roll back fast. That's a bit of a golden rule with the company. We don't start debating how the protocols and which packets are being missed, just roll back. But also maybe have a rollback button, which some companies really use for a particular time. So let's say, 5 hours ago, everything was working smooth. And now we just roll back to that configuration. We had to stay at that network in that time. Stuff like that. already mentioned that we also want to do flows configuring devices. Of course, that's key. It's very valuable. And with that, we can also maybe start looking at the software rollout. So we can validate. So what we do, for instance, when we operate something, we isolate a particular device, make sure redundancy is up and running. We check everything is okay. Then we're going to do the upgrade, make sure everything is okay, and then bring the device back into the production network. This can all be automated as well. Another thing, security. Of course, security, we didn't talk too much about it this presentation. But security is very important as well, because there's always a bug somewhere, or an access list, or someone trying to attack the network. So we need to have a method of when identifying there's something wrong and update it very quickly as well. So this is key for us as well. It could be just a simple access list. It could be just rolling out a new software, or whatever. But you know, we've got about 20,000 devices. We need to have a method of going to doing it very fast. And of course, I mean, we can go on the list of all the stuff we can think of. I can think of a lot of things, just to keep it limited as well. The last topic, you know, I touched about it previously as well, is just collecting the telemetry, creating these data lakes. Again, we all read about it. Using these algorithms. But let's just see first, right, if there's an interface which is flapping, which is a very simple case. We have now the means to detecting it, but also to take action together with the companies we're working with now. So just say shut the line down. Because you know, there's all kinds of mechanisms. If a packet is not being received 3 times, the line will shut down. But sometimes it's, you know, 2 packets are not received for the 3rd one again, and it's causing a lot of problems for the customers. Just a flapping line. And we can, of course, make it much bigger. With all the dreams we can think of, right? We can have CPEs talking to each other. So it's CPEs, the machine learning that comes from CPEs. That's what I wanted to say. Together maybe with the network experience from the customer, so the network satisfaction of the customer. And we can also add external sets to it as well. You know, whether I've seen some companies doing it already in America, I saw some companies. The weather forecast, we work with HFC network. When it gets warmer, it behaves differently than when it gets colder. So we might be able to shut off some particular frequencies or take actions where we know it's going to happen. Power grids, the most big thing we suffer from is power outages, and you know, we have got a very good power network. You don't even complain at all, but every time, 9 months in them, maybe we get a power outage for maybe 5 minutes per week. Now, some of these things are also maintenance, and we've been trying to we've been engaging with power companies, give us a schedule and stuff like that, but maybe there's also a system available where they just fill in the system, we couple it with our systems, and we can see, look, these systems are going to go down for the next 5 minutes, something like that. It still happens to us a lot. There's a big outage, and it turns out that the power company did tell us there was going to be power outage, but somehow it was lost in translation. So this is just some examples we can work on together as a collective. And I mean, I could talk for another hour on this. I don't have that much time, but just to show you also our ambition, where we want to go. We want a fully automated network, not only makes it easier for us to operate, but also makes it easier for the customer to get much more information, and we become much more friendly to the customer. That's basically the aim we have in this work group.